This is part 2 of a two-part series on U.S. gasoline supply. It is an updated version of a model that was configured several years ago and has been used for capital project decisions. Part 1 described the seasonal adjustment of the raw data into a long-term trend and a seasonal term. The long-term trend is the focus of this video, and is shown as the blue line. Since the early 1990s, the general direction of this trend has been up. However, something changed in 2007. The obvious question suggested by this graph are: what happened at the peak in 2007 to cause the trend to roll over? Why is the trend currently dropping? Will it continue to drop? And when will it bottom and turn up? Various groups commonly provide forecasts. Here's a 2012 forecast from an organization that has been trusted for more than a decade. Is this a turning point? Are things about to improve? Before we get too excited about this possibility, let's look at the forecast back to 2007 from the same group. Clearly, there's room for improvement. With the exception of the 2009 forecast, none of these forecasts are even in the right direction. Why would anyone trust this group when it comes to a forecast? It turns out that before the 2007 turning point, their forecasts were reasonable. They were fairly accurate for more than a decade. It's likely that the trust that built up over the years was more related to a consistent trend in the data than in the forecasting skill of the organization. Other firms have been tracked and they also provide questionable results. It's clear that something has to change. The forecasting process needs to be open, verifiable, and hopefully simple. 3 obvious questions need to be answered. First, what is a reasonable forecast for the direction of U.S. gasoline supply? And why? Second, are we at a turning point where the growth in gasoline supply is about to turn positive? And last, is there a reasonable explanation for the 2007 turning point? The rest of this video is designed to address these questions. We start off by extending the data backward as far as possible. This zoomed-out view provides more perspective for the recent downturn. In order to forecast that blue line, a model of the growth of that line has to be estimated. As in the previous slides, the blue trend line is still scaled on the left axis. However, the annual % growth rate of the trend has been added. As shown in red, the growth rate is scaled by the right axis. It has a range of -10% to +15% a year. The horizontal gray line is the 0% growth line for the right axis. In other words, whenever the red growth line is above the gray line, the blue trend has a positive growth rate. And when the red growth line drops below the gray line, the blue trend has a negative growth rate. It is this red growth line that will be modeled and used for forecasting. But before we do that, it is useful to highlight the general phases that gasoline supply has passed through over the years. First, there was a high growth rate around 10% per year just after World War II. That rate drifted down to about 3% by the mid-1950s. Those dips and rises were related to the 1949 and 1954 recessions. Next, growth swung above and below 3% for over 20 years. In the late 1960s and early 1970s, a common belief was that the energy business was recession-proof. That changed when in the late 1970s, the price of gasoline doubled and then tripled, and the economy went into the 1980 and 1982 recessions. This was the first sign of a maturing gasoline market. As the price came down and the economy recovered, the growth in gasoline supply stayed mostly positive for another 20 years, swinging around 1.5% a year. It turns out that improvements in gas mileage and changing driving habits are correlated with this lower growth condition. Which brings us to current conditions. The steep decline of the 2008 recession hit consumers hard, and correlates nicely with the drop in gasoline supplied. However, the 2007 turning point formed before the recession started. Of all the other possible explanations, the most likely reason for the turning point was related to the high price of gasoline. So, to reproduce these characteristics, the proposed gasoline supplied growth model consists of four components. First, a ramp term from 1945 to 1954, modeling pent-up demand after World War II. Second, a constant term after 1954, modeling relatively stable growth, up to about 1978. Third, a real gross domestic product term, that captures the swings in economic activity. And fourth, a gasoline price term, that provides a reasonable estimate of the effect of high and low gasoline prices. Graphically, the ramp term is a sloped line that starts in 1945, at a growth rate of 10% a year, and ends in 1954, at a little less than 3%. Next, the constant term is added. It starts at a little less than 3% a year in 1954, and ends at the same level in 1978. Next, the real GDP growth term is added. It is simply a scaled version of real GDP growth. As shown by the blue line, in the smaller graph, real GDP growth typically drops below zero during recessions, that are represented by the gray bars. The idea is that growth in gasoline supplied is positively correlated with growth in economic activity. So, adding the real GDP term helps with the overall fit. Notice that this term helps explain some of the dips and bumps from 1945 to the mid-1970s. However, it isn't enough to explain what happened after 1978. Clearly, there's something else related to these swings in gasoline growth. It turns out that for the last few decades, a very influential factor has been the price of gasoline. When the price is high, gasoline supply growth declines. When the price is low, gasoline supplied growth rises. As shown in the small graph, the blue line is the real gasoline price. We'll get into the details of this price term in a few minutes, but for now, the main issue is that the real price of gasoline has swung between high and low prices over the last 40 years. When this term is included in the model, it noticeably improves the fit. So, the completed gasoline supplied growth model consists of four terms. The ramp and constant terms dominate the model before 1978. The gasoline price term dominates the model from 1978 to now. And the real GDP growth term helps explain the effect of general economic activity, but does not dominate the model at any time. With the model fully defined, let's tie up that loose end of where the real gasoline price term came from. As presented a few slides back, the real gasoline price graph shows the swings in real price over time. It is simply the ratio of the actual gasoline price to a gasoline price that is consistent with the Consumer Price Index. As shown, the green line is the Consumer Price Index, or CPI, scaled to fit the price of gasoline using ordinary least squares. It provides an unbiased gauge for the price of gasoline. So, to calculate the real gasoline price, the blue line is simply divided by the green line. The result is the real gasoline price graph that was used in the model. As you can see, before the mid-1970s, gasoline followed the CPI close enough that it was neither cheap nor expensive. However, it swung from expensive in the 1970s and early 1980s to cheap from the mid-1980s to 2005. Since 2005, gasoline is expensive again. According to this gauge, today's $3.73 price is too high by about 66%. With these large swings in price, it shouldn't be a surprise that the real gasoline price is an important factor in the growth model. And that since about 1978, the price of gasoline has been the dominant factor. We now have a way to address those three questions about the growth rate of U.S. gasoline supplied. Since the questions are about recent activity, notice that after 1978, the first two model terms no longer apply. The ramp term ended in 1954, and the constant term ended in 1978. The real GDP growth term is proportional to the real GDP growth rate, and the gasoline price term is proportional to the ratio of the price of gasoline to the scaled CPI. These relationships can now be used to answer the three original questions. Answering the first question requires both the model and some assumptions about its inputs. For example, the gasoline price term requires a value for both the consumer price index, which is just accumulated inflation, and the price of gasoline. The two graphs on the left-hand side are a set of popular assumptions for 2012 through 2013, along with their probabilities. The lower left graph shows a 1% probability of $2 a gallon gasoline, a 4% probability of $2.50 a gallon gasoline, and so on. Similarly, the top left graph shows assumed inflation rates of 0% to 5%, with their associated probabilities. These two graphs provide enough information to calculate the gasoline price term for the model. Next, the assumptions for the real GDP term are in the upper right-hand graph. The range is from a recessionary -2% a year growth to a robust positive 3% rate. The probabilities favor the 2% a year rate. All of these assumptions, along with the model equations, were used to generate the red forecast that is shown in the lower right-hand graph. The forecast gasoline supplied growth rate could be anywhere from -4% a year to +1% a year. But the odds favor a value around the mean forecast of -1.7% a year. Plotting that red forecast on the original graph verifies the intuition that future growth will probably continue to be negative. The solid red line is the mean forecast growth rate of -1.7% a year, while the upper and lower dashed lines are the 5% tails. That answers the first question. The last two questions deal with turning points. A turning point is simply where the gasoline supplied growth rate goes from positive to negative, or negative to positive. In either case, it crosses the zero growth line. With growth equal to zero, we can rearrange the model equation, providing a turning point formula for zero gasoline supplied growth. It depends on the CPI and the real GDP growth values, and when plotted on the price graph, provides an easy way to recognize turning points. The zero growth line is shown as the dashed gray line. The 2007 turning point took place when cheap gasoline in 2005 crossed over decisively into expensive gasoline. As long as the actual gasoline price continues to stay above the zero growth line, gasoline supply will continue to decline. That means today, we are nowhere near a turning point. The current price of gasoline would have to drop below $2.50 a gallon to fall below the zero growth line. That may or may not happen down the road, but as of June 2012, the odds don't favor gas prices at low. So, it's no mystery why some oil companies have abandoned the retail segment of the U.S. gasoline business. A shrinking market is a difficult place to make money, and there are other segments that offer more potential.